Let's say you're given a problem where you have to set the highlighted elements here in the square matrix to 0. Okay, so to solve problems like that, you have to come up with a strategy. Let's quickly try to do the same. Let's follow the standard convention of using I for rows and j for columns. Okay, so I'm just going to write I equals to 1. So when I say I equals to 1, I'm pointing at the first row. Now, let's see what values j is taking in here. Okay, so j looks like it's starting with 1, and then 3, and then 5, and so on and so forth, if this were a bigger matrix. So basically it's starting with 1, and it has a step size of 2. Alright, so instead of, writing 5, I'm gonna make this more generic. So let's see if I can write an expression for j in terms of the number of rows or columns. Because the number of rows and columns in a square matrix are equal, so I'm just gonna write 1 colon 2 colon rows. Okay, so let's see if this holds true for the first row. When I is 1, j is 1 colon 2 colon 6, which is 1, 3, and 5. So we're good so far. Let's look at the second row. Okay, so when I equals to 2, j is 1 colon 2 colon. If you observe closely, the number of column elements that are being selected, they are decreasing as we go further and further in terms of rows. So let's see, I'm just writing this up. We can validate this later. So I'm going to write rows minus 1, okay, and see if it holds true. So j equals to 1 colon 2 colon 5, which is 1, 3, and 5. Still true. I'm going to write the same for the third row. So where I is equal to 3, j is equals to 1 colon 2 colon rows minus 2. Let's check if this is holding true. So it's 1 colon 2 colon rows minus 2 is basically 4. So we have 1 and 3. So now the solution is starting to take a shape. Let's go even further. Once I hit like the last row, my I is equals to number of rows that I have here, and my j sort of just became 1. Okay. We are almost there. We almost solved this problem. All I have to do is write out a generic expression for selecting the column elements. So let me write it out. So I'm going to write j equals to 1 colon 2, and then I look for a pattern here. Okay, so I'm starting with 1, rows minus 2, rows minus 1, and rows. So what's happening here is when I is 1, I have this value as rows. When I is 2, I have rows minus 1. When I is 3, I have rows minus 2. So I could write rows minus I plus 1. Okay. All right. So looks like we arrived at our solution. Let's validate this. So when I is 1, this condenses to 1 colon 2 colon rows, which is true. When I is 2, this condenses to j equals to 1 colon 2 colon rows minus 1, and so on and so forth. Now all we have to do is write nested for loops. I'll write for I equals to 1 to rows. All right. I'm going to write for j equals to 1 colon 2 colon rows minus I plus 1. Okay, just to make sure that it looks clear. Now, I'm just going to access the elements this way. So let's say this matrix is mat. Okay, so I'm going to use mat I comma j equals to 0. Sorry for those sounds, but yeah. Anyways, here it is, the solution for this problem. So what we did was we looked at the pattern of I and j. We just figured an expression that could generalize this to any sort of arbitrary sized square matrix, and then we wrote this out. Okay, so yeah, I hope you're comfortable with problems like these, which require you to access specific elements in a matrix and do stuff with them. Okay, cool.